Hey guys, today we're going to talk about writing and graphing inequalities. First of all, let's talk about a few definitions. An inequality is a statement formed by placing an inequality symbol between two expressions. An inequality symbol is any symbol that indicates that the expressions are not equal. For example, a less than sign, a greater than sign, a less than or equal to sign, or a greater than or equal to sign. A solution of an inequality with a variable is the set of all numbers that produce true statements when substituted for the variable. Let's take a look at a few of these. So if I give you x is less than 3, that means all numbers less than 3. All numbers less than 3. So if I were to substitute in, say, like a 0 for x, 0 is less than 3, so that is a solution of the inequality. So is -1, -2, -3, -4, and as you can see, my number line does go on forever and ever. Now I want you to notice the symbol here that I used when putting it on the number line. I used an open circle here. I used an open circle because 3 is not a solution of this. If I put in 3 for x, 3 is not less than 3. It's equal to 3. So that's why I use an open circle, because I'm not including 3 in that. In my second example, I show y is greater than 2, which means if I substitute in 3, 4, 5, or even decimal numbers in between there, like 3.5, all those numbers are greater than 2. Again, I use an open circle because 2 is not a solution here. In this next one, though, I use z is less than or equal to 4. That means all numbers less than 4 would work. 3, 2, 1, 0. But notice the symbol I use here. I use a closed circle, a filled-in dot, because in this case 4 is less than or equal to 4. It's actually equal to. So yes, I'm including 4 in this particular inequality. And in that final one, n is greater than or equal to -2. 2 is again a part of my inequality. Or sorry, -2 is a part of my inequality. So is -1, 0, 1, and 2. Make sure to get all of this written down, guys, so you can see the difference between symbols. Although the variable, as you can tell, isn't that big of a deal. So let's look at an example. The freezing point of water is 0 degrees Celsius. At temperatures at or below freezing point, water is a solid, in other words, ice. Write an inequality that gives the temperatures at which water is a solid. Then graph the inequality. Well, the freezing point of ice has to be less than 0 degrees. Well, so that's less than. It does say at or below, so that means it can actually freeze at 0 degrees Celsius. So in this case, all numbers that are at 0 degrees or less than 0 degrees would actually work. It also says then graph an inequality, guys. I got to make sure I pay attention to my directions because it tells me to graph also. So here I've got a number line and I'm going to label it. I'm going to put a 0 here, a -1, -2, -3, -4, -5, -6, and then I'll put a few positive numbers in there too, just so you can tell where we are at on the number line. Now, because it says less than or equal to, I'm actually going to put a closed dot on there. Fill it in, and then I'm going to shade or highlight all numbers that are less than 0. Now, some people will actually do this above the number line and not on the number line, and that's just a matter of preference. So if you were to do a closed dot here above the 0 and fill it in this way, that is perfectly okay also. Again, it's just a matter of preference there. Let's look at another example. A cyber cafe charges users a minimum fee of $2 for internet access. Write an inequality to represent the access fee, F, then graph the inequality. Well, I'm looking at F here because that represents our fee. Now, they're going to charge them a minimum fee of $2. So they will charge them $2. But they could also charge them more. They could charge them $2.50. They could charge them $3. So that tells me here I need an equal to sign here as well as a greater than sign, because numbers I plug in could be $2, $3, $4, so on. Now I'm going to graph my inequality, so I'm going to include a 2 here. I'm going to also include numbers less than 2. And numbers greater than 2. Now, because my sign says greater than or equal to, I'm going to use a closed dot again. And then I'm going to fill in all numbers that are greater than 2. So there I have an inequality written as well as a graph. The other thing you could do is to actually have to write a graph based on the inequality. So let's look at this. I have a dot here between 0 and negative 2. Well, what's that number between 0 and negative 2? That's a negative 1. I also have an X, and it shows greater than. Numbers that are 2, 4, 6, those all work. So the smallest my number could be here is a negative 1, so I actually want my arrow to point at the negative 1. Can my answer be negative 1? No, it's not a closed circle. So my inequality as x is greater than negative 1. On my second inequality, the largest my number could be is 6. So I want all my numbers to be less than 6. Again, your variable here doesn't really matter, so choose your favorite variable here unless the problem tells you which one to use. Now, could my variable here be equal to 6? No. It's an open circle. So I leave it as y is less than 6. For my final example, you see that my dot is between negative 4 and negative 6. So that right there looks like a negative 5 to me. The numbers that are represented here are all bigger than negative 5. All my positive numbers are represented. So the smallest it could be is negative 5. But I want everything bigger than negative 5. And again, my variable doesn't really matter, so I'm going to do h. Now, can it be equal to negative 5? Yes. And in my final example here, I'm going to use the variable f this time. I'm looking for numbers smaller than negative 2. So less than negative 2. Can it be equal to negative 2? Nope. I've got an open circle there. Now, if you have any questions on this, Panthers, make sure that you write them down so that I can answer them tomorrow in class.